Welcome to this subsection on error sanctioning and training and optimization. Considering our output, which is a three-dimensional tensor of dimension batch size, sequence length, and vocabulary size, we would have something like this for each batch, where we have each batch having a dimension L prime VO. So this is L prime and then VO. Now with this tensor for each batch, we could calculate the loss, and this loss is given as the cross entropy loss or the categorical cross entropy loss, because in this case we have several categories to choose from. So if we pick out, this is one batch, and if we pick out now for each strip in this length L prime, because we have 1, 2, 3 up to L prime different outputs, so for each of these we could calculate the categorical cross entropy loss, which is given with this formula. We've seen this already, and then what we simply do is we calculate this and then simply add this up for all the different elements. So all we'll need to do is just to define our categorical cross entropy loss right here. Now it could also be the sparse, we could also use the sparse categorical cross entropy loss, but the way we've set the output such that it has dimension 3 or 3 different dimensions makes us use the categorical cross entropy. So in the case where we have the batch size L and then V with a vocab size, we'll use the categorical cross entropy. But if we just had the batch size and then this and then this, so if we actually, instead of having the 1 hot representation and put that 1 hot representation into just the maximum values for each 1 hot representation, it will give us this. And if we're using this, then we'll use the sparse categorical cross entropy. But for now, we shall use the categorical cross entropy loss. For the optimizer, we use the Adams optimizer. Learning rate, start with 1 times 10 to the negative 3. Number of epochs, I could say 100 epochs. So that's it. Then we don't go to training. We have this. Good load. Let's take this off. We have some callbacks. Monitors the loss, the minimum loss. Save the best weights, and then we could fit our model. So yeah, we have the training, the validation, and that's fine. So let's run this. After training for over 100 epochs, we have the results. We'll see how the loss drops from about 7 and goes down to 0.51. So we could keep on training so that we could have smaller loss.